Okay, good morning everyone. We have a smaller audience, but go through details, basically what we've been doing in AOSP upstreaming with X15 as the reference platform, and what has been the upstream progress so far, and what is in the near future work. So the session will be split into three main parts. One is the problem statement, what we are trying to do with respect to internal product development and use the community as a reference with the reference platform, and how do we reduce the development effort with pastry migrations and test cycle and all of those, and why basically H15 is a good candidate compared to a bunch of reference platforms which are already available, and the status of AOSP reference platform guidelines, and basically going through the hardware and software requirements and reviewing why our platform is most in the ready category, and covering through some of the key features, what are important for Android, and what is upstream status so far, and what we'll be working towards in the next few months. Okay. Basically, since past many years, I mean, this is one example of TI development, but I'm sure most of the companies does in the same way. Basically, we fork platform manifest from Android in a mirror in some internal or publicly available repository, and add bunch of platform-specific fixes and HALs and features. Reviews are done mostly in an internal fashion, where like wider audience is not available, so the quality of the fixes and features is not in the highest standard possible. And the testing with limited use cases on the limited platforms is what many will do. And then release SDK based on a given pastry, and restart the cycle on an S pastry. So what's the problem with this? Larger pastry migration cycle. I mean, I clearly seen people spend many months to even sometimes like more than 6 months in just doing a pastry migration, and large effort when we have to introduce new platforms, even though they are the same platform variant, or introduce new platforms which are completely new, even though there is code reuse because the code has not been done in a nicely weighted fashion for upstreaming. There's a bunch of rework that has to be done on the new platform too. And given the testing has been fairly limited in a more manual way, the testing is very limited, and it basically we are spending a lot of time in all this work which is supposed to be boring. So where we want to go with example of X15 is have one of the reference platform which is upstreamed, and then have the platform available in such a way that we just download repo init of Android Google source platform manifest and build with launch target, and the images should boot to a minimal bootable quality with basic Android functionality ready, so that we can do the full compliance and testing and run some benchmarks of Android. We will still end up forking pastry because Android keeps moving on a on master. So on a given pastry tag, if you want to validate, we might have to backport the fixes from master. So the forking is still needed, but given that a primary reference platform is mainlined, the amount of fixes which might be carried is done in a vetted way, so that we also review in the fashion of when getting it upstreamed immediately. Yeah, we do have to review patches based on the reviews that's happening in gerrit Google source for master, and also cherry pick them on a given pastry tag. More test automation will help in increasing the test effort for the X15 platform, and also scale to more new platforms. This model, even though we'll start on the new pastry tag, given that most of the basic functionality is there and the platforms are tested in most automated way, the level of pastry migration cycle is much reduced. So why X15? There are already like many 64-bit platforms already available as a dev platform for AOSP. Pixel is one example, Dragonboard, Nexus devices, and high-key platform. X15 caters to a unique platform, and basically it's also one widely available open platform. Basically TRM, schematics, and documentation is widely available, and it's well supported by community. And it is one of the only ARM32-bit platform which is currently actively doing pastry migrations and based on LTS cycle. And all of the other reference platforms based on ARM64 are based on like mobile reference platforms. So this caters to a unique area where embedded automotive and industrial segments, that's where we've been actively using, where the requirements are a little bit different from what mobile requirements are. So the documentation is available publicly, and we've been actively updating that. That's our URL there. So before Google considers some platform as a reference platform, they do provide some guidelines on what the hardware requirements are and how it should be, and also what should be the minimum software requirements. And these are some of the summary of key requirements what they requested, and this is just a good example. If some other company wants to have their platform as a AOSP reference platform, they can refer the same and see if their platform is ready in the context of these to get their platform as a reference platform for AOSP development. As I said earlier, the S15 is widely open, available in market, even for Google or anyone in community to get the board. The documentation is available public, and one of the requirement was the RAM size has to be decent, and for X15 it is 2 GB. And it has good internal eMMC space, barely enough to do the Android current use cases, but this is good enough for the existing features and also the next pastry requirements. It has 5 USB ports needed for various Android use cases like ADB, MTP, PTP, mass storage kind of use cases. Networking, Ethernet is supported, but even Wi-Fi with the Wi-Fi module can be connected as an add-on card. That capability is available on the hardware. And on software, some of the requirements are asked is like it has to be supported for 2 years at least once the platform is upstreamed. And we are doing that with the example of the Linaro triage team, and since the past many years with the LCR releases and LKFT releases. So the history of the platform with community support is known, so the next 2 year support is not a huge risk. And it should have an open bootloader, which we've been doing actively, and also a LTS kernel support. The platform is mostly upstreamed, so all these are already available. Some of the key functionalities needed for Android is the USB for ADB kind of use case where we can have to test the compliance. So that is also upstream. And we should use the Android common kernel. So given that LTS-based Android common kernel is available fairly sooner, so we do integrate that actively with our auto integration cycle. And one requirement is no never-ending crash loops. Basically what it means is Android package manager, service manager, or graphics should not crash, and that we fairly keep it active and ensure that those are not broken, and we do review the LKFT test results and getting it fixed. The next, multimedia is one of good to have requirement, but we do have X15 mostly ready with software, video, and audio decode features already supported in mainline. GPU driver, the kernel module is GPL licensed, and it is out of kernel tree integration we do, but that is available in public. It's not like an internal kernel module. And the user space module is firmware, and that's also available in public. One of the requirement is all this is done in the context of treble development and how we develop Android across various platforms and ensure the updatability is faster. So treble is important for Google, and this platform we've been developing treble since many years, and so it's not a completely unknown area. So this is a little bit busy slide. Basically what I'm trying to show is as AOSP master development is happening, in parallel, a pixel-based development happens, and the fixes are carried from the master, or when a given tag is announced, with the example of 4.14 LTS and Android Pie tag, a few months before itself, the pixel baseline development happens, and when the Pie tag is announced, pixel device is ready in the market. When a given tag is released, that's where Linaro starts looking at the baseline and starts making LCR-based releases, adding additional platform support, in this case Hikey, and we've been adding X15 in this category. So basically, as you can see, once a given tag is announced on a given Google Experience device, there are at least 2 platforms available in LCR who are testing and ensuring the Android is not broken with the basic compliance on at least 2 platforms. Our baseline, whatever we do as a device support baseline for kernel U-boot and Android pastry, is same between LCR and also for internal development. So it's the same Git repositories. So, but we do test on additional platforms which are also available in public, and internal platforms too. So whenever we do the platform support across various areas in U-boot, various domain trees, and also device and HAL, while we test first on LCR / the internal development baseline, whatever makes sense, we do get it into master at the same time, getting it reviewed. And once the next pastry tag is announced, the fixes are already available, and then we have to look at a smaller set of patch set. Ideally, we want to go to 0 for the common frameworks, but there will always be needed some fixes which we have to carry in an immediate pastry release. So as you can see from this, basically upstream and downstream development is happening in a proactive way than reactively looking at issues later. This is basically a summary of what are all the features what we've been developing across U-boot, kernel, and Android OS. These are the 3 main areas where we've been upstreaming features, and thanks to help from Google, they've been fairly helpful in reviewing our code and getting the right review comments so that we can getting it fixed and getting it upstream to master. So this is the status as of now. Initially, AOSP U-boot tag was much older, like 2018 or 2017-05 based, and we have to get it updated to the main, like at least to 2019-01 U-boot tag, where our platform is already there in the mainline U-boot. And then the basic platform enablement, and for Android use case, eMMC is already part of that U-boot tag, so those came indirectly in that. We are doing with eMMC as the primary boot media, but even we can switch to like a SPI-based boot media. There are some fixes needed for fast boot to enable this part, and the development is in progress. SPI-JS basically gives better and faster boot support. Device partitioning is today static, and that part is already mainline based on the current U-boot tag, and there is dynamic kernel partitioning that is coming next, needed for Android, and that along with that, the reboot reason, basically rebooting to and stopping in bootloader to flash the new super partition, and that requirement is going to become mandatory, and we are working actively to get that enabled in the near future, hopefully by Android Q timeframe. Android verified boot 2.0 and also system A and B both go hand in hand, and those fixes are almost ready to be integrated in mainline, but once they are there, we'll just have to request Google to update the U-boot tag. There is no work that has been started with Clang yet. Clang is one of the requirements from Google long-term with respect to having all Android projects move from GCC to Clang. The primary focus has been kernel, but this is one of the low-hanging in radar to have U-boot support Clang-based build system. More details are there in the URL shown here, and whatever are the new bootloader requirements, those will be actively updated here, and as a supported platform, any company has to actively review what are these and accordingly enable them on a given platform. In kernel, the basic platform support, as I said, it's in mainline, so even if someone wants to take 5.0 kernel, X15 itself boots to kernel command line. We've been using device tree and overlay with fit model, and that is also available and in our integrated kernel, and we've been actively using and integrate Android common kernel and Android config project of a given LTS. So these are all already done on our integrated baseline. Clang build works, so on kernel, but some more testing is pending, so eventually we have to switch to Clang-based build in our production-based testing. EMMC and ADB is already mainline, so there is no pending work there. And the kernel drivers for ALSA, OMAP, DRM-based display is already mainline, so those work out of the box. Buffer allocation, there has been active work that's happening, and we do want to switch to Ion. It will eventually be called some other name, but there is good effort happening between TI, Linaro, and other members to having a D stage for Android and non-Android use cases, and it might be called DMA buff heaps, at least the allocation part, but this is something which we are actively helping with respect to upstreaming. PVR kernel is one part which is not mainlineable, but we have the sources available and we do integrate it as out of tree module. On the AOSP side, basically when we introduce the platform, Google has to create all these projects, the device project and the hardware TI SOC project, and then accordingly, once those projects are created, we added the basic platform support, ensure the launch and command to boot till command line it is ready, and then we added the treble support and SLNX policy fixes to ensure the enforcing mode is functional. ADB is supported, and also PVR firmware is added inside the device project. Device Beagle X15 kernel project is basically the reference image which is needed for ensuring the image is built from the Google build system, and it is needed for their CI loop and better updatability, and this is one of the requirement, and that project is also actively tested with the CI loop and also LKFT. Hardware TI SOC is basically where we all enable all the device specific HALs, and today we enable the hardware composer 1.0, and there is a work happening to migrate to hardware composer 2.1 and switching to the external DRM hardware composer project instead of the fork what we did for our SOC specific one. Hopefully that will be ready by the next pastry. Boot control HAL, this is needed for Android verified boot and also AB kind of functionality, and it is there in AOSP master, but since given that AB and AVB is not yet in U-boot, the development, we cannot consider it as completely done. So once the U-boot changes are integrated, we do have to do some more production testing and close this part. The next effort is audio HAL integration, and we have to move to a generic audio HAL very soon. Then we had to make some additional fixes in external libdrm to add OMAP device and dynamic kernel module loading for kernel module loading support, and bunch of compliance fixes across AOSP all projects. And once all this is done, manifest with the device project is added. Yeah, that's basically a summary. I mean, there are so many features that the time is short that we cannot cover in detail. But the next steps is, given that the platform is already in mainline now, we do have to update the source.android.com and having the documentation available so that anyone can build and boot and use it. And CI loop of H15 is not there yet, so that's the next step. We are working with Google to enable it. This is for the basic build and boot test across Google's, apart from our ARM32 platform, Google tests all x86 and their emulator, simulator platforms and all other ARM64 platforms. And the current baseline is 4.14 based. We've been actively testing 4.19 internally, so that equivalent of AOSP update will happen in the next few weeks. And Android Pie, which is a current pastry, is tested actively on LTS-1, so we do have to test more on LTS baseline and start fixing the compatibility and compliance issues and have a better baseline ready. And as mentioned in the previous slide, the main two areas where the active development is happening is Bootloader and enabling the HALs. And anything new that is going to come in Android Q and Android for automotive is what we are focused in the near future to enable. Okay, that's mostly what I have. Anyone have any questions? Okay.
Have a question? So, what would it take to add support for X15 in mainline for Android Auto? Is this like a great chunk of work, or it's like will work out of the box?
We did some experimentation on Android Oreo, so it's not a huge unknown. So basically we have to enable a new launch target enabling the automotive specific product packages, and the HMI interface will look different, so we have to readjust the display resolution, and also the Android test compliance for automotive is a different project, so all those have to be tested. So we did test a variant of X15 platform with that, so it's something that can be done fairly quickly. Anyone else? Okay, thank you.